Hello students, Professor Nugent here. In this video we're going to discuss the least squares dummy variable estimate. We can take the perspective of the AI as parameters to be estimated for each I, which is feasible given enough time periods. We do this by including a dummy variable for each cross-sectional unit without using an intercept. So we have n plus k parameters, n for each of the dummy variables for the cross-sectional units, and k for each of the explanatory variables. And if we include year dummies, which we absolutely should always include our year dummies, we'll want to include t minus 1 year dummies. If we include the full year dummies, then we'll end up with multicollinearity with the n cross-sectional dummies, the dummies for the AI. So we'll include t minus 1 year dummies so that we actually have n plus k plus t minus 1 parameters. And then the least squares dummy variable estimator in the least squares dummy variable model is the following. We can write yit is equal to, we have no. Okay, this is beta 1 times x1 it through beta k xkit plus, now let's include our year dummies, delta naught d2t. So we start with the second period, we leave the first period out, through, let's see, we want delta as our coefficient on the dummy variable. This is delta that's t minus 1. T minus 1 because we have t minus 1, and I guess if we start with 0, it would be t minus 2. So let's just start with 1. Delta 1 and delta t minus 1 d t, and then include our dummy variables for the cross-sectional units. And we can use gammas for this. So we have, we'll call that AI are the parameters to be estimated. So we have A1, gamma 1, where gamma 1 equals 1 if the observation is cross-sectional unit 1, if it corresponds to cross-sectional unit 1, and 0 otherwise, through an gamma n. So we estimate the AI, the gammas are the dummy variables, plus UIT. And this is for t equals 1 through t, I equals 1 through n. So again, the dt t, this is the period t dummy, and the gamma I is the unit I dummy. The interesting thing about the least squares dummy variable model is that the estimates of beta 1 through beta k hat will be identical to those of the fixed effects model, given that we have also included the full set of period t dummies in the fixed effects estimator. So the least squares dummy variable estimator is algebraically equivalent to the fixed effects estimator. The thing is that it has much higher degrees of freedom, right? Because you're estimating many more parameters. And so the fixed effects estimator is computationally more appealing. There are some other nuances to the least squares dummy variable estimator that we should discuss. This can be thought of, this approach, as trying to estimate the AI as omitted variables. The problem is that the estimators, while they are unbiased, the estimators are not consistent. Each time that we bring in an additional cross-section, as the sample grows unboundedly towards infinity, we're bringing in new cross-sections, so we're bringing in new AI. We have new information, we have new heterogeneity. And so our estimators will not converge. So they're not consistent because you're always bringing in new heterogeneity with each cross-sectional unit. Sometimes the individual AI may be of interest. Say for a particular firm or person, maybe you want to know if they are above or under the average. And particularly, the estimates of the AI are not usually reported when you estimate a fixed effects model or a least squares dummy variable model, especially when there are very many units in the sample. Fortunately, we can estimate these AI using the averages over time. The AI hat is equal to yi bar minus beta 1 hat x1I bar through beta k hat xki bar, right? So we use the averages over time to estimate the AI if they're not already reported. We should tread carefully in interpreting the R squared. The R squared with the least squares dummy variable model is probably going to be much higher than if we estimate using fixed effects However, it's really hard to say that we have added much explanatory power to the model using dummies. Keep in mind that this stuff that we're controlling for with the dummies, it's still unobserved. And these estimators are not consistent. So by controlling for this stuff, we're not really controlling or explaining variation using data, right? So don't get too excited if you see a very high R squared by adding unit dummies. Those unit dummies, what you're controlling for, is still unobserved. Alright, so that's it for the least squares dummy variable model. The takeaway is that least squares dummy variable is equivalent to fixed effects. Sometimes you hear then one referred to as the other interchangeably. And sometimes the AI are of interest, but we should tread carefully with the R squared. We should also tread carefully with trying to read too far into estimating or interpreting the values of the AI, because the coefficients, these are inconsistent, and unobserved. Stay tuned to the next video. We will discuss how to think about when we should use fixed effects versus the first difference estimator.